Hey, and welcome back to the lab. And today here on the bench we have a little power amplifier. So for its own, that is really nothing exciting. But you know, it is a kind of interesting because the power amplifier here inside, so the power transistor popped. And the interesting point is that it is still working. So we see that the lid popped off, and we can see a little bit inside the transistor. And I think that is something interesting to somebody of you, because we can look into the transistor with our microscope and see how it is constructed inside, and of course we see that it is still working. And of course we have to change this transistor, this power transistor, because this little amplifier is used for APRS solutions, so it is still in use. So therefore, of course, we fix it, but I thought that might be an interesting point to see. Okay, and here is our setup, set to 29 megahertz, because as I said, APRS setup, and radio here is set to 5 watt output power. So it is now here running through our relay inside our little amplifier. So we see more or less the 5 watt on our power meter. So now that is nothing special. I press the PTT and we get approximately 4.4. So that is because it is running through our little amplifier. And of course I can switch it in, and now I need to put this wire to plus, because that is normally connected to the rig which drives this little amplifier, and then our TX-RX relay here inside will switch, and then it is working still just a little bit. And that is what we see. Not really. So it is dying more and more. Yeah, you see 6 point, and now it is dropping because, yeah. So, I mean, a transistor like we have it here in this little unit can't really work any longer. But yeah, let's let's look into the transistor. And here you can see the whole board, and now when I go closer, and you see the camera is not able to deliver what we really want to see, because that is the reason why we go over to the microscope in a bit. Here we have already our replacement type, MRF 455, and you see that the white lid is completely gone, and yeah, it was not even here in the housing of the amp, so don't know what has happened. But let us look exactly to the transistor through our microscope. That is more interesting. Okay, and here we have it. So we are really looking right into the inner of our transistor, and what we see down here, so the more blue one, are the silicon elements. So what we see is that for a power transistor like this, we have more than only one element. And what we see here around, so that are our leads where the transistor is soldered to the PCB, okay? And you see that to the different leads here. So base, collector, emitter, what we have on a normal bipolar transistor. You see that from the elements here, from the silicon elements, you see all the little wires which goes here to the material here, and you see that it is bonded here to our copper or whatever it is. And what we see as well is, if you look very carefully, one of these connections here, this one, okay, so that is disconnected here from where it should be connected to. So you easily see that 1, 2, 3, 4, 5 are connected, but that one here in the middle, I can't really grab it. It is so small, but you see that that is missing. And of course, if one of these elements or modules, or however you want to call it, is missing, then of course the performance of the entire power transistor is gone. So let me see if we can go even a little bit more here into the details, so you really can see all the fine wires which are connected one for one to the outer material where we solder it in. And I mean, so you see it here. So that is where it is soldered finally to the PCB. I think that is really nice to see, that you get an impression how that all is made. And even an IC or whatever silicon component we have is always something like this. But of course, if you have an IC with a high density, all these elements, these silicon elements, are much smaller. We are talking here about a power transistor, and of course we have here bigger elements, if you can talk about bigger elements, because they are still very, very small. And well, we need to dissipate, we need to sink the heat directly here from the silicon elements. So that all is very exciting to see, because all the whole element here is put here into this to this metal, which also works as a heat sink. And now under that construction it can really work. And here again an impression how the setup is here with my microscope. And when we go closer, you may really get an idea how small that all is. And you see my camera is not able to pick it here any longer. So I hope that was a bit interesting to you. And now we go and replace here the transistor, of course, with a new one. And of course, the first what we need to do is we need to desolder here all the connections here from the switches, and here from our antenna sockets, and what have we, to be able to lift here our PCB in order to get to the underneath of the PCB to get the transistor off from the board. Alright, and all connections are off, and now we should be able to lift it, and we can. And now we can flip it, and it really does not look so good. So also the heat component is not that nice here on the board and on the chassis as well. Anyways, let me take the broken one out, and then let's go ahead. Now, when you're doing those jobs, it is always good to have here a solid PCB holder, because sometimes it is a little bit tricky to get the transistors out, and I always try to use first my desoldering gun to get most of the solder off before we really try to lift it off. So that means we really go down here and we heat it up. It is always you know, a real my station was going down to standby, which is of course not wanted. So now it should work. Now it is melting, and now I can already suck here the first off, and that is how I always do it, right? So going here really first down to the PCB and take really the most of the solder off, as much as possible, and you see how clean it already gets. So yeah, that is how I'm doing it. The next step is then I take here this blade tip, as you can see it, and then of course I try to get here under the leads to lift them a little bit, and that makes it easier to really get those kind of transistors off. And when you already have worked here a little bit through, I don't know if you really can see it. So you see I really can go here underneath, and then I can get the lead here free to finally remove it. So that is a process. I do it now, of course, at all here our leads, and then it should work. Okay, and our transistor is off, and you see they have here an eyelet, which is here connected, of course, to emitter. So that is a little bit tricky for the new transistor, but anyways, we will get it managed, and we need to take care on the right orientation, of course. But yeah, now first we clean here our pads. Well, the challenge here with this really little amplifier is to finally get here the transistor centered, because if we do it wrong, and we simply would take here the transistor and put it down here to the PCB, and then just solder it, it might at the end that you know, you do not get your screws here through, because as we discussed it before, the transistor is underneath, and the screws are coming here from the top through, so that is here an original screw, and we put it here from the top through the transistor down to the chassis, which is finally our heatsink. And now the problem is to get here that really good adjusted, that finally it really works. And you see now when it is in, I really need to mark it here somehow, and hopefully that I can then tuck one lead to the PCB to finally have it in the right position. You see, I have now the markings here on the transistor, and now when I lift it here off from this little helper construction, I hopefully can now, let me see, I hopefully can now take the transistor and can put it now somewhat in exactly the same position, and I really need to do it off camera, because otherwise I will really not get it really fixed. And now when I hold it, or trying to hold it in this position, I try to tuck it here at one point to finally have it really as we need it. And now I used here the eyelet to put the original screw through it, and I just fixed it here at the bottom side, as you can see, so that it is more or less not too loose, let me call it that way. And now I'm able to align, and it is finally aligned. So you see that what I've put here down with my pen is now aligning here to what we have in reality, and therefore I can now try to just tuck here one of our leads to the PCB, and then we can do a final test if it still fits to our chassis, and if that is working out good, I really can solder it down as we finally need it. Alright, and as discussed, I have now tucked it down here, here and there, just a little bit. And now let's try if we can get it here into our test jig, and if that will work, we are fine. Yeah, and I would say that is pretty promising. So it fits, so that means that when I take afterwards the original screws here from the top, it will definitely fit. So you see how tricky it really can be to fix such, you know, a little power amplifier. So you really need to take your time to get it all right. Okay, everything is done. The new transistor is in, and our board is entirely reworked because we really had a lot of dry solder joints, so we really reworked everything. And now let's put it back here in our housing, and then we are ready to test. And of course, before we put it back here into our housing, we put of course some thermal component here to it to make sure that the heat transfer is as best it could be. Right. Okay, so everything is back together, and important right now is to check here the input SWR from our radio into our little power amplifier, because after we have changed here our power transistor, that is important to check. So that is the first what we do. So radio is set here to 5 watt output power, so that should be fine. And when I'm now pressing the PTT, you easily see that the SWR is fine, but in the moment we only have the loop. So our power amplifier is not in line, right? Next step, of course, is we switch it in, as we have it here. And now, of course, it is very important to see what our output power is, but it is minimum important as well what our input SWR is, because now we are, you know, through our little amplifier. And let me demonstrate it. If it is not really aligned, you see that the SWR could be completely wrong. So therefore this setting here is crucial to have the best input SWR, okay? And now from this position, so that you see it is still here our setup, and we have up there our power meter. And now when I key with 5 watt input power, when I now key, here's a PTT, we have 82 watt output power. So let me zoom in, that you may see it here a little bit better. So you see the little amplifier is really working great with 82 watt output power, so that is great. And here now our last picture of this episode. So job is done, everything works fine. So 83 watt output power, so that still is really nice. So nothing to complain, really happy with the outcome, even it is only a little and easy power amplifier. Now it can go back in the RPRS setting, and of course the operator have filters which now gets behind this amplifier, because you know this little amplifier do not have any output filtering. So that means a lot of harmonics will be available without any low pass filter at the output. And therefore, of course, in the setup there is an external filter. So for anybody who might ask, it is all as it should be. Okay, so that's it for today. Thanks for watching, and catch you next time. Bye.